In this video we will be looking at mathematical relations. A, B is said to be an ordered pair consisting of the elements A and B. We consider A to be the first element in the ordered pair, and that means that B is considered to be the second element. A relation is a set of ordered pairs. Every relation can be separated into two sets. The domain is the set of all of the first elements, and the range is the set of all the second elements. A relation can be defined by a rule. So examples of this include the set of ordered pairs x, y such that y is equal to x squared. And another example could be the set of ordered pairs x, y such that y equals 2x plus 4, where x takes the values 0, 1, 2, 3 and 4. And we'll investigate this particular example in a moment's time. If the domain is not specified, so in the second example we had a specified domain, x was these certain numbers here, whereas in the first example we had no domain specified. When no domain is specified, we generally assume it to be the real numbers. A relation can be defined by a rule. So we saw this rule before, and if we sub 0 into this rule, we have 2 times 0 plus 4 gives 4 out as the second element of the ordered pair. So we'll have an ordered pair 0, 4. Similarly, if we put 1 into this, we have 2 times 1 plus 4 gives 6. So we'll have an ordered pair of 1, 6. So if we continue that, we find all the ordered pairs for this relation, and they've been listed here, and you can check that, for example, if you sub 4 in, you have 2 times 4 is 8, and 8 plus 4 gives you the 12 as that second element in the ordered pair. The domain is the set of numbers 0, 1, 2, 3 and 4. So that was this domain up here, which was already specified in our rule. And the range is the set of all the second elements in the ordered pairs. So 4, 6, 8, 10 and 12 form the numbers in that set. For simple cases, we can represent relations using arrow diagrams. So we're going to have a look at an arrow diagram for this. So we can see that the first element 0 has an accompanying number of 4 in its ordered pair. 1 has 6, 2 has 8, 3 has 10 and 4 has 12, which are the ordered pairs shown in the highlight now. For our arrow diagrams, we have an arrow that's drawn from the first element to the second element, and we need to note that arrow diagrams are very limited for relations with an interval domain. So that's where the numbers are continuous between 2 points. For more complex cases where we do have interval domains, relations can be also represented using a graph. So here's an example where we've plotted each of the ordered pairs on our graph, and we can see that the first element is plotted on the horizontal x-axis, which is this axis here in red, and the second element is plotted against the vertical axis, often known as the y-axis, which is this axis up here. The implied domain of a relation is the largest set of numbers for which the rule has meaning. So when a rule is given for a relation but no domain is specified, we understand that that relation exists over its implied or maximal domain. And often this is the real number set, but there are some cases where certain numbers don't have meaning for a rule. So if we consider y equals x squared, the maximal domain is x is an element of all the real numbers. So if we graph that, we can see that every x value has meaning for that rule, no matter how large or how small it becomes. If we then consider y equals the square root of x, the domain is x is an element of 0 included to infinity. And that's because we can't have the square root of a negative number. It has no meaning for that rule. So when we plot it, you can see that the graph only exists from 0, 0, this point here, off to infinity in the positive direction. None of the negative numbers have meaning for that rule. Consider the relation described by the set below. Represent the relation on a graph. So what we need to do is plot each of these ordered pairs. So if we consider the first point, we have negative 3, 1. So that's negative 3 on the x-axis and 1 on the y. So that point's there at negative 3, 1. Next we can consider this point, which is negative 1, negative 1. So negative 1 is in this position here. Next we have negative 1, 1. So negative 1 on the x, 1 on the y. So that's negative 1, 1. Then we have the point 0, 1. So we have 0 on the x, 1 on the y, which is here. And finally we have 2, 0, which is 2 on the x, 0 on the y, which is this point here. Next, we want to state the domain of this relation. So the domain is the set of all of the first elements in the ordered pairs. So we have -3, -1, 0, and 2. So we have -3, -1, we only list that once, and then we have 0 and 2. So they are the set of all the first elements in the ordered pairs, which is the domain. Next, we want to state the range of the relation, which is all of the second elements in the ordered pair. So we have 1, -1, 1, 1, and 0. So again, we have the set of -1, starting from the smallest value. Then we have 0 and +1. And we only list the elements once, even though they appear multiple times. For our next example, we want to consider the relation described by a rule, and that rule is y equals 1 divided by x minus 2 all squared. So we want to represent this relation on a graph. So you should be able to see that this is a truncus rule, and if we have a look at the denominator, the value of x that has no meaning for this rule is x equals +2, because that would give a denominator equal to 0, and we know that we can't divide by 0. So that means there's an asymptote at x equals 2, which is this line I've just drawn in here. And the other asymptote that exists for a truncus graph is a horizontal asymptote, and this one is at y equals 0, and that's what I've just drawn on there. Next, we can draw our truncus graph, which will look something like this and like this. And the last thing we need to find is the y-intercept of this graph. So the y-intercept occurs when x is equal to 0. So when x is equal to 0, we have y is equal to 1 divided by 0 minus 2 squared, which gives 1 divided by 4. So this point here is 0, 1/4. For part B, we want to state the domain of this relation, which is all of the x values that have meaning for the rule. And as you can see, there is only one x value that has no meaning, and that's x is equal to 2. So the domain of this graph is x is an element of all real numbers excluding 2, because that's the asymptote, and that's the number that gives 1 divided by 0, which we know is not possible. For part C, we want to state the range of the relation, which is all of the y values that are generated by our rule. So our y values are y is an element of, and the smallest y value that is generated is very close to 0. And to represent that, we put 0 with a round bracket, which says it gets very close to 0, but it is not included. And then we go up to our highest y value, which is infinity for this rule. And again, infinity has a rounded bracket on it. So after this video, you should be able to understand that a relation is a set of ordered pairs. You should be able to represent a relation using a graph or an arrow diagram. You should be able to state the domain and range of a relation. And you should understand that relations that are described by a rule have an implied domain.